Yeah, should do that.
No. You're so funny. You dress up today.
I am dressed up.
You can't be yourself.
No, I'm not myself.
What are you?
I'm an athletic director.
Oh, that is.
No, I'm the assistant athletic director in real life, and so I dressed as the athletic director today.
Okay.
Yeah, Al.
Wow.
Well, see, I was going to look. We at one point we had a green dinosaur costume at home, and I was going to be an Allosaurus.
And why aren't you?
I couldn't find the green dinosaur costume.
I have a blow-up costume.
Okay, well, that's all right. All right.
You should have dressed up as Alvin and the Chipmunk.
Yeah.
Oh, that one would actually been good.
Yeah.
Mm-hmm.
You could have found 2 other people that did the other ones with you.
Mm-hmm. Theodore, so somebody whose name starts with a T. Troxel. And Simon S. Swenson. Yeah, Swenson could have done it. Mm-hmm. Okay. You guys are really trying to make me not teach here.
What do you mean? No.
Can you explain that?
Do you know what I dressed up as?
Savannah Snow.
Super cool Savannah Snow.
Oh, okay. Yeah. All right. So there was.
Who is? Maria. Is she really? Yeah, she's wearing all brown.
Wait, how many foreign exchange students are there?
3?
4.
4?
4 of them.
Okay.
Who?
Paola, Maria, and that other one that plays volleyball. What's her name, Bierschbach? Julia. It's not Julia, Maria, and the other girl play volleyball. And Paola does tennis. Paola does tennis. But there's 3 that are in volleyball.
Okay. Well, we'll look at the volleyball roster later after I get done teaching.
Well, you won't be able to find it because
we're gonna forget about it if you don't do it right now.
She's not on varsity.
I could get to the other rosters.
How? Can you do that now?
All right. So, all these people watching the video are going, would you just start already?
You can pause the video.
Okay. There was 2 reasons why calculus was invented. One of them was to find the slope of a curve at any point upon the curve. The other one was to find the area under a curve, because by those 2 things you can solve many, many different types of problems. Okay? So, let's look at this problem. Let's answer these various questions starting with this one over here. What's the average rate of change from 1, 1 to 2, 4? Well, 1, 1 is right here. 2, 4. Boy, that's a crabby graph. Wait, no, it's right here. It's not so crabby. Okay? How do you find average rate of change? What are you telling me?
Slope.
Thank you, Kate. You are correct. Average rate of change is slope. So in this case, it would be 4 minus 1 over 2 minus 1, which is 3 over 1, which is 3. So the slope between these 2 points is 3. Now, let's say we want the slope just at the point 1, 1. Well, how are we going to find a slope at just 1 point? Because the slope formula uses 2 points. Well, this equation is y equals x squared, right? So if you put in a 1, you get 1. If you put in a 1 for x, you get 1 for y. If you put in a 2 for x, you get 4 for y, right? What if we put in 1.1 for x, which is, let's change the color, which is about right here. Well, what's 1.1 squared? 1.21. So smart. Good job. So now let's take this point and find the slope. So let's go 1.21 minus 1 over 1.1 minus 1. And we get 0.21 over 0.1, which is 2.1. So the slope between these 2 points right here is 2.1. How about we get even closer? How about we go, let's go with a different color yet. How about we go 1.001? That's really close to 1, isn't it? What's 1.001 squared? 1.002001, right? That what it says on your calculator? Okay. So let's find the slope between this point here and this point here. So 1.00201 minus 1 over 1.001 minus 1, which is 0.002001 over 0.001. How about we divide these on a calculator? What are we going to get? .001, right? So the first slope we found was 3 between 1, 1 and 2, 4. The second slope we found was between 1, 1 and 1.21, which is 2.1. The third slope we found was between 1.001 and 1, which is 2.001. So this seems like we're doing something from last chapter. Remember when we had the table? So we were at 2 and the slope was 3. Then we were at 1.1 and the slope was 2.1. Now we're at 1.001 and the slope was 2.001. It's like we're trying to get from all the way down to 1. And what should this number be? It's like we're getting closer and closer to something. It's like we're finding a limit. Oh, and the slope, we're getting closer and closer to the number 2. So what's the slope at 1, 1? Well, it would be 2 in this case. We just found a limit. That whole chapter we just did goes directly into this chapter. Imagine that. What's the slope at 0, 0? What do you think the slope at 0, 0 is going to be? It's going to be 0. Why? Because the slope is a measurement of the tangent line to the point. And that's going to be a horizontal line. Hi, Ellie. And then, so let's find the slope at 2, 4. Okay, so let's do another limit. So from 1, 1 to 2, 4, the slope was 3. Okay, so let's go at 1.9. Well, what's 1.9 squared? Because y equals x squared for this thing. So what's 1.9 squared? 3.61. So let's find the slope between 2, 4 and 1.9, 3.61. So it's 4 minus 3.61 over 2 minus 1.9, which is 0.39 over 0.1, which is 3.9. Okay. Let's find the slope at 1.999. What's 1.999 squared? 3.996001. Okay. Between that and 2, 4. So you go 4 minus 3.99601 over 2 minus 1.999 equals 0.00303999, right? Over 0.001, which is 3.999. What's the slope at 2, 4? We were at 3, then we were at 3.9, now we're at 3.999 as we're getting closer, so the slope would be 4. The slope at 0 is 0, the slope at 2, or 1 is 2, the slope at 2 is 4. Slope, and then the x value. So the x value is 0, has a slope of 0. X value of 1 has a slope of 2. X value of 2 has a slope of 4. What would an x value of 3 have a slope of? 6. Okay? So the slope is just 2 times x in this case. For x squared, it's 2x. You'll learn in a couple sections how we get from there to there.
Ellie is an explorer. Yeah. Do you like my...
That is so cute.
Thank you.
Dora, Dora, Dora the Explorer. Okay, but it's Ellie, Ellie, Ellie the Explorer. So, who's your sidekick? It's not Boots, it would be...
Kate. Kim K.
Okay. Coots?
Coots.
Coots. All right, the average rate of change for this over this. Okay? Average rate of change is what? Slope. Kim Kardashian gave us that a little while ago. So, if you're ever finding average rate of change, you want to find the slope. How do we find the slope? Well, we find h of 2. What's 2 plus 1? 3. 2 to the third is? What's h of 4? Well, 4 plus 1 is 5. 2 to the fifth is? 2 to the third power. I probably did. It probably came out of my mouth.
Isn't that 27? 3 to the third?
Yes.
Okay. So I wasn't stupid. Don't laugh at me.
All right. So 2 to the fifth is 32, right? So when you're finding average rate of change, these are the y values. These are the x values. y2 minus y1 over x2 minus x1. 32 minus 8 is 24. 4 minus 2 is 2. Average rate of change is 12. Okay? When you find average rate of change, you're finding the slope. We sometimes have to plug in to find the slope. Let's find the average rate of change over this interval. So you're finding h of 5 and h of 8. Because it's over this interval, you do the two endpoints. What is h of 5 if you plug in a 5? It is 1/5. What's h of 8? 1/2. So you take y2 minus y1 over x2 minus x1. So multiply top and bottom by 5, multiply top and bottom by 2. So you get 5/10 minus 2/10, which is 3/10. So it's 3/10 over 3 over 1, right? Complex fraction, how you get rid of a complex fraction? Well, we'd multiply by the denominator of the denominator, but the denominator of the denominator is 1, so we multiply by the reciprocal of the denominator. 3's cancel, and we get 1/10. The average rate of change in this function is 1/10. The slope of the secant line that intersects the graph of that at those 2 points. A secant line is something that hits it at 2 points. A tangent line is something that hits it at 1 point. So the secant line, we plug in the 3, and we get 15 minus 6 is 9. Square root of 9 is 3. We plug in the 7. 15 minus 14 is 1. The square root of 1 is 1. So the slope of the secant line is still, we're finding slope. y2 minus y1 over x2 minus x1. Negative 2 over 4 is negative 1/2. Slope of the secant line. We're 2.1. Estimate the slope at 3. Here's 3. Estimate the slope of the tangent line that hits it. Okay? It goes something like that. Which of these match that? Only one of them does. There's only one that's close. You know that if a line goes down from left to right, it has to be negative, so it can't be that one, can't be that one. A flat line, a horizontal line is 0, so it's either this one or this one. Does this look like a slope of 1/3 or a slope of negative 3? 1/3. Negative 1/3. Goes down 1 for every 3 it goes over. Okay? All right. This notation, this is important. The most important thing of the day, because this is the whole first semester, is this right here. This means the first derivative.
No. I hear people on Instagram reels talking about this.
The first derivative.
I used to hear it on TikTok.
The first derivative is the slope at a point. That's what we use to find the slope at a point is the first derivative. So if it says the first derivative at 3 is 4, that means the slope is 4 at an x value of 3. The slope is 4 at an x value of 3 if it has first derivative. Now, this is a point. That's a point. What point is that? Well, it has an x value of 3 and a y value of negative 2. You have a point. You have a slope. They go together to make point slope form. And you'll use point slope form a lot. What is point slope form? It's y minus y1 equals slope times x minus x1. Okay, this is from Algebra 1, point slope form. You might even learn that in pre-algebra, that possibly. But point slope form, okay? So if we stick these two things into point slope form, what does it match over here? A, B, C, or D? No, all of them are in point slope form, Kim. Come on, let's get Kate back and let's ditch the Kim.
I lost so long. B.
It is B. Slope x1, y1. minus a negative is plus a positive. Y minus y1 equals slope times x minus x1. Okay? So, when you see this notation, it is the first derivative, which tells you the slope. So I'm going to be harping on it the whole chapter all the way up until the AP test in May. When you see a derivative, it means slope. Derivative, slope. Derivative, slope. That's what you have to understand. If you understand that a derivative is a slope, it makes this class so much easier. Okay? This whole chapter is the basics of derivatives, which think slope, derivative, slope. Okay. Tangent line to a graph at the point there passes through there. Okay? What's the slope at 1? Well, if it's a tangent line passing through there and there, we have 2 points. We can find the slope. Our points are 1, 5, and 3, 4, correct? To find the slope, it's y2 minus y1 over x2 minus x1. Negative 1 over 2. Our slope is negative 1/2. This symbol says we want to find the slope. First derivative is the slope. First derivative is the slope. So our answer is the slope that we found. First derivative is the slope. Okay? So you must understand this notation signals that this is a derivative. The first derivative is the slope at the point. Second derivative is the concavity. But we'll worry about concavity in a future chapter, not this chapter. Okay? That's like chapter 5 or something like that. So that's more like November and December. You will be fine, Kim.
No, that was Explorer, not Dora.
Oh, I'm sorry, Dora. Okay, so that's the basics of this section. So we'll do one section now, and I have a 3-sectioner that maybe I'll just cut down to one section, and then we'll do 2 more on Friday. Okay. Oh, I could cover 3 of them in 45 minutes at the end of this class period. So, right, I know. So what I'm saying is I will have plenty of time to cover 2.